In our first example, we are just going to be practicing finding critical values because remember, we are now working with the t-distribution. One thing I will say, I am very particular about notation, how my students write things. If we are working with the t-distribution, your critical value needs to be a t sub c. In the previous lesson, when we were working with the standard normal distribution, we were writing z sub c because they were z-scores because they came from the standard normal distribution. But if they come from the t-distribution, they are not z-scores, they are t-scores. So you would need to write t sub c. Again, how you know which one you should be writing all depends on whether or not you know the population standard deviation or not. Okay, there we go. Okay, so let's practice finding a critical value. We have a 95% confidence level and the sample size is equal to 15. So I know that C is equal to 0.95 because that is our confidence level. N, the sample size, is 15, which means that the degrees of freedom is 15 minus 1. Because remember, the degrees of freedom is n minus 1, so we have 14 degrees of freedom. I'm going to show you two different ways you can find this critical value. One, using the t-table. And then I'll show you also how you can find it on the calculator. If we are using the t-table to find it, I'm going to be starting with the 95% level of confidence. Our level of confidence was 95%. And our degrees of freedom in this example was 14 because our sample size was 15. So now I'm going to see where the 14 degrees of freedom meets the 95% confidence level, and they meet at 2.145. And so our critical value, t sub c, is equal to 2.145. Remember, we do still have two critical values, but just like from the previous lesson, we will only be using the positive ones in the formula. That's not a great curve because these tails are thicker. This is a better curve. So if we're saying that we have 95% of our data in the middle, remember, we are forming confidence intervals. We want to form some interval and be able to say that 95% confidence that what we're looking for is in there. We found the positive critical value of 2.145. And remember, critical values are what separate usual data from unusual data. So anything that's not shaded in orange would be considered unusual in this example. And so the negative critical value is definitely negative 2.145 because this is symmetric. They have the same value but with the opposite signs. So we have seen an example of how to find the critical value using the table. Now I want to show you how you can find the critical value using your calculator. So I'm going to draw the same picture, but this time I am not going to put the critical value on it because I'm pretending like I don't know it because I'm going to show you how to find it. So remember that the total area under this t-curve is still 1. The total area under this t-curve is still 1. So if I have 95% in the middle, then 1 minus 0.95 means that I have 5% shared in both of the tails, because everything should add up totaling 1. Now if there's 5% in both of the tails, then in just one of the tails, like say this one, it should be 0.05 divided by 2, which is 0.025. So what we are looking for, if I want to know what this critical value is, I'm looking for the t-score that has a left area of 0.025. A t-score that would have a left area of 0.025. You also could have found this one, but it doesn't really matter because they're the same number with opposite signs. So I am going to now go to my calculator, and to find that t-score with a left area of 0.025, I'm going to hit second bars to go to distribution, and I'm going to go down to number 4. I'm going to go down to INVT. I can't hit enter. There we go. It's going to ask me for an area and a degrees of freedom. Well, when it asks for area, it is asking for the left area of whatever you're... It is asking for the left area of whatever you're looking for. And we just found that that left area was 0.025 and our degrees of freedom was 14. And then I'll hit enter, and it will give me negative 2.14478, which does round to negative 2.145. That rounds to negative 2.145. So that means that we have just determined that that question mark is really a negative 2.145, which means that the other critical value has to be a positive 2.145. So now you know how to find critical values on either using the standard, not the standard normal table, don't say that, using the t-distribution table or using your calculator. And you'll do an example of that on the next slide where you find a 90% confidence interval for a sample of 8. I do want to go ahead and mention now that when your degrees of freedom is not in your table, then you will use the closest number in the table that is less than the value that you need. Or you could always use technology, like I just showed you with the calculator, to find the critical value. So for example, if you're doing the problem and your degrees of freedom was 57, if I go to the table, there is no 57 on here. It goes from 50 to 60. Then you would use something with 50 degrees of freedom. You would use one of these numbers depending on whatever your confidence level was. Use the closest number that is less than that. So if our degrees of freedom was 57, then we would end up using 50 degrees of freedom if we were using the table. Or, of course, you could always use the calculator, and then when you went down to MT, you would just enter in that your degrees of freedom was 57, and that would give you your critical values as well, depending on whatever your level of confidence was. So go ahead and try the next example on the next slide before we look at some examples of how we will construct confidence intervals when we do not know the population standard deviation, because we were not going to be able to build these confidence intervals unless we definitely know how to find these critical values.